Welcome to the Unveil Investigation Team. Subscribing and liking helps us keep asking the questions that matter to you. And remember, we unveil so you see. In this series, we uncover the hidden geopolitical and geological truths shaping our world. Today, we are looking at a localized threat so severe it could wipe out millions of people in a matter of minutes. This 3D cross-section reveals what lies beneath Lake Kivu's peaceful surface. The distinct, permanently separated horizontal water layers hide a massive reservoir containing roughly 60 cubic kilometers of dissolved methane and over 500 million tons of carbon dioxide. These immense gas deposits cannot vent naturally into the atmosphere. They are actively trapped by the extreme hydrostatic pressure of the water above them. The immense weight of the water column forces the dense gas to remain compressed and completely dissolved at the lowest depths. This physical dynamic creates a highly pressurized geological bomb, perfectly disguised as a tranquil rift lake. Scientists have a specific name for what happens when this underwater containment fails: a limnic eruption. This diagram illustrates the physical trigger process. If a physical disturbance breaches the lake's stratified layers, the deep pressurized water is forced upward. As the pressure drops, the trapped gases rapidly expand and violently break out of solution. At the surface, this creates an explosive release. A dense, opaque fog of toxic gas bursts outward, moving across the landscape at highway speeds. Because carbon dioxide is significantly heavier than air, the cloud hugs the ground. It aggressively displaces all oxygen in its path, causing anyone caught inside to collapse and suffocate in under 60 seconds. The gas is invisible and completely odorless. Its overwhelming speed and silence render standard human survival instincts and emergency responses entirely useless. Directly above this chemical trap sits dense, sprawling city infrastructure. These neighborhoods are packed tightly against the shoreline, with active volcanoes looming right behind them. Approximately 2 million people currently live inside this immediate topographical danger zone. Their exposure is actively worsening. Rapid population growth in the region continues to drive massive new construction directly on the water's edge. The human footprint is expanding blindly into a natural kill zone, geometrically multiplying the potential death toll of a future eruption. Despite the known lethality of the lake, authorities possess zero capability to predict exactly when an eruption will occur. For the 2 million residents lining the shore, there is absolutely no established evacuation plan. There are no designated escape routes. Compare this massive peril to the almost non-existent mitigation efforts currently in place along the shore. Hazard management often amounts to little more than a flimsy, hand-painted no swimming sign stuck in the rocks. Instead of public safety, government and corporate attention is dominated by industrial methane extraction. Floating platforms pull gas from the lake for a multi-billion-dollar energy payoff. The population has been functionally abandoned by the institutions meant to protect them, leaving 2 million citizens as mere collateral in an energy extraction experiment. Without a warning system or an escape route, survival depends entirely on the lake's fragile physical equilibrium remaining unbroken. Active volcanic lava flows from the nearby craters could easily penetrate the lake's depths, instantly shattering that equilibrium. Structural triggers are just as dangerous. Seismic activity or a massive landslide off these sheer, steep cliff faces could plunge into the basin and violently mix the separated waters. Ironically, the human engineering interventions designed to extract the methane could themselves inadvertently disrupt the stratification, acting as the very spark they are trying to manage. Any of these triggers, whether natural or man-made, would act instantaneously. There would be no precursor, no sirens, and no countdown. The fuse is permanently lit. 2 million people go to sleep every night next to an active detonator that could trip at any second. Picture a geological time bomb capable of releasing a toxic cloud so massive it wipes out everything in its path. For years, the global consensus has warned that Lake Kivu holds a staggering 2.6 billion tons of trapped carbon dioxide. If triggered, that specific mass of gas would violently erupt to the surface, forming an invisible, ground-hugging fog. Because CO2 is heavier than air, it would sweep through the surrounding valleys, aggressively displacing oxygen and causing suffocation within minutes. You can find this exact 2.6 gigaton figure everywhere. International media outlets and major global organizations, including UNESCO, repeat it as the definitive, unquestioned measure of the threat. But if you trace the citations backward, the trail doesn't lead to a geological survey. It leads here, to a widely circulated feature article published by Nature magazine in September 2021. Curious, digging into the text of this prestigious feature reveals a strange forensic dead end. There is absolutely no citation linking that 2.6 billion ton claim back to any primary limnological literature or field surveys. The most terrifying and frequently quoted statistic regarding this African geological hazard is an orphaned number. It rests entirely on a single, uncredited sentence. The sheer institutional prestige of the publication acted as a shield. It allowed a completely unverified number to bypass the normal scientific immune system and infect the global consensus. To understand the actual threat, we have to look past the fabricated mass and focus on the physical volume of the trapped gas. This diagram shows Lake Kivu's deepwater geometry, where dissolved gases form a distinct layer of 300 cubic kilometers. That measurement is anchored in empirical surveys from 1974 and reconfirmed by the Swiss Federal Institute of Aquatic Science. We determined the true mass using raw physics. By applying the ideal gas law at standard temperature and pressure, that 300 cubic kilometer volume converts to a strict numerical range, exactly 500 to 600 million tons. That data puts the true physical reality at roughly 589 million tons. The widely accepted media fiction is nearly 4.5 times larger. The authoritative 2.6 billion ton figure simply exceeds the physical limits of the lake's rigorously surveyed deepwater geometry. Massive floating industrial platforms now conduct commercial methane extraction directly within this hazard zone. Industrial engineers and corporate patent filers building these multi-million-dollar rigs cannot rely on inflated media claims. They have to base their technology on verified raw data and the uncompromising constraints of actual operational reality. When we check two independent U.S. patent filings related to Lake Kivu's gas extraction, both cite the same foundational survey data. And both independently arrive at figures between 423 million and 600 million tons. The corporate engineering patents align with the independent physics calculation, solidifying the 500 to 600 million ton range as the factual baseline. When financial investments and engineering safety are on the line, the inflated 2.6 billion ton figure vanishes, replaced by the rigid constraints of actual physics. If the physical chemistry of the lake doesn't equate to 2.6 billion tons, what exact mathematical formula generated that number? We must zoom out to global environmental statistics. The recognized metric for total annual human-caused greenhouse gas emissions is exactly 52 gigatons. The original feature claims the lake holds exactly 5% of global emissions, and 5% of 52 gigatons is exactly 2.6 gigatons. That 2.6 billion ton figure aligns with that arbitrary percentage, rather than the lake's actual volume or pressure. The number was reverse engineered to provide a clean, easily digestible, and terrifying comparison for a Western media audience. Inflating a geological hazard might make for compelling headlines, but it corrupts the scientific baseline required to actually plan mitigations and design effective evacuation routes. This manufactured scale obscures the 500 million ton operational reality actively threatening the millions of people living on the shoreline, leaving us to question who actually benefits from an inflated narrative. Plunging deep into the dark abyss of Lake Kivu, massive industrial pipes are quietly siphoning off a deadly threat. Down in these deep, pressurized waters sits roughly 60 cubic kilometers of highly volatile methane. But drawing this gas to the surface serves two purposes. It slowly vents a geological time bomb before it reaches a critical pressure threshold, and it harvests a highly lucrative resource. That extracted methane is pumped directly into shoreline power plants, currently generating roughly 21% of Rwanda's national electricity grid. Up in the green rolling hills surrounding the lake, high-voltage transmission towers carry that newly harnessed power to thousands of homes and businesses. What was originally conceived as a safety valve to diffuse a natural disaster has evolved into the indispensable backbone of a nation's energy strategy. To understand why this operation is scaling up, you have to look at the math drafted by regional governments over a decade ago. Technical reports mapped out a maximum capacity scenario for the lake's methane, projecting an economic yield of up to $42 billion over a 50-year lifespan. That staggering upper bound figure creates a powerful gravitational pull. For private energy operators and local authorities, extracting the gas is a massive commercial enterprise. With $42 billion on the line, Lake Kivu has been reclassified. It is an active, submerged gold mine. But the push to harvest that gold mine has fractured the scientific community. Lake Kivu's safety relies on a delicate physical structure. This cross-section shows the lake's thermal staircase, distinct stratified layers of water, methane, and carbon dioxide stacked on top of each other, held in equilibrium by water pressure. The extraction plants pull water up, remove the methane, and pump the degassed water back down. Independent hydrodynamic models flag a serious concern. If that wastewater is discharged back into the lake at the wrong depth, the turbulence could violently disrupt those stable layers. If the stratification breaks, the deep water surges upward, causing the dissolved gases to rapidly escape. The very pipes installed to prevent a limnic eruption could theoretically trigger it. In the rush to secure a national energy source, the engineered cure carries a terrifying, unquantified risk of becoming the detonator. While the financial models and engineering diagrams are meticulously detailed, the safety protocols for the people living above the gas are entirely absent. Despite decades of warnings, neither Rwanda nor the Democratic Republic of Congo has established a standing civil evacuation plan for the lake's shoreline. The extent of the official preparedness amounts to a scattering of isolated warning signs posted near the water, with 0 public drills, 0 sirens, and 0 actionable escape routes. Looking at the sprawling coastal cities sitting directly beneath these volcanic mountains, the scale of this oversight is staggering. Roughly 2 million people live directly in the immediate blast zone of a potential toxic gas cloud. And rather than clearing the danger zone, development is accelerating. From dense urban centers down to small thatched roof homes inches from the surface, new construction continues to crowd the shoreline. The deepwater gas has been meticulously valued at $42 billion, but the human lives on the surface have been entirely left off the balance sheet. They remain exposed to a catastrophe they will never see coming. Before dawn on August 16, 1984, a man walking along a dirt road in western Cameroon came across a pickup truck parked on the shoulder. The local priest was slumped inside, dead. Further down the road, he found another body on a motorcycle. Then a flock of sheep collapsed in the grass. Then more vehicles, all with dead occupants. The fatalities here followed no obvious logic. In one stalled truck carrying 12 people, the driver and passengers got out to check the engine and died instantly. The only 2 survivors were sitting on the vehicle's roof. Authorities found 37 bodies along that stretch of road, with no visible injuries. Initial theories scrambled to explain the scene as a political massacre, an infectious disease outbreak, or a biological weapon. But the forensic chemistry told a different story. This was the first documented strike of an invisible geological killer. 2 years later, the same mechanism triggered at nearby Lake Nyos. This time, the scale was catastrophic. This cross-section shows the anatomy of a limnic eruption. In deep crater lakes, volcanic vents can saturate the bottom layers with dissolved carbon dioxide, held in place by the weight of the water above. If a landslide or tremor violently mixes these layers, that gas escapes all at once, erupting into a massive, invisible cloud. Carbon dioxide is heavier than air. At Lake Nyos, the gas formed a density current that hugged the ground, spilling over the crater rim and into the surrounding valleys at 100 kilometers per hour. As it swept through the lowlands, the cloud physically displaced all breathable oxygen. Exposure caused brief dizziness, followed by unconsciousness and suffocation within seconds. The official death toll reached 1,746. Survivors described a total, eerie silence across the valley. Even the flies on the bodies had been killed. These deaths were the result of a known threat. 2 years earlier, researchers had already identified the exact mechanism responsible. In the aftermath of the Manoon deaths, a volcanologist successfully isolated the CO2 degassing process and documented the high levels of dissolved gas remaining in the lakebed. He submitted a paper detailing this mechanism and warning of an ongoing threat to the journal Science just months before the Nyos disaster. The journal rejected the paper. Reviewers dismissed the findings, claiming the proposed gas release was too far-fetched to be a credible danger. By dismissing the evidence as impossible, the establishment left thousands of people living on the shores of similar crater lakes entirely unprotected. Today, that same threat exists at Lake Kivu, a container vastly larger than the lakes in Cameroon. The volume of gas here changes the stakes. While the Nyos disaster was caused by 1.2 cubic kilometers of gas, Lake Kivu holds 300 cubic kilometers of carbon dioxide, alongside massive pockets of explosive methane. The risk is amplified by human geography. Unlike the remote valleys of Nyos, Lake Kivu's shores are home to dense urban centers, with houses built directly at the water's edge. Approximately 2 million people live in the path of a potential eruption. Yet 40 years after the first warning signs in Cameroon, there is still no standing evacuation plan for a gas release at Kivu. The gas continues to build, and if a rock slide, a volcanic flow, or a failure in the extraction pipes finally disrupts the stratification of these waters. On August 21, 1986, residents of villages near Lake Nyos in Cameroon went to sleep just as they had any other night. The air was quiet and conditions were perfectly normal. But inside the ancient volcanic crater holding the lake, an invisible threat was waiting right beneath them. Deep underwater, volcanic vents had been pumping carbon dioxide into the lake for years, building toward a rare event known as a limnic eruption. Deep water pressure keeps the carbon dioxide dissolved, preventing it from bubbling up. It functions like a pressurized, unopened soda bottle. The gas is trapped in a highly concentrated bottom layer, held in check by the weight of the water above. That invisible pressure lock had been quietly accumulating gas for hundreds of years. The thousands of people resting in the surrounding valleys were sleeping beside a geologically active payload, unaware of the massive volume of gas suspended in the water column directly below them. At approximately 9:30 p.m. on the night of the disaster, that long-held geological equilibrium finally broke. A sudden disturbance, such as a minor earthquake or a landslide along the crater wall, struck the lake. This physical impact caused the lake's distinct stratified layers to violently mix, breaking the pressure lock. Once the lock failed, the carbon dioxide-rich deep water rapidly came out of solution. As the gas raced into the lower pressure environment near the surface, it expanded massively in volume. A purely chemical cold gas expansion drove the eruption, powered entirely by the sudden release of pressure. A slight physical shift in the deep water had triggered an unstoppable cascading chain reaction. A massive, invisible, and odorless cloud of carbon dioxide detonated from the lake's surface into the night air. The initial vertical jet ripped out of the crater at roughly 100 kilometers per hour. Because carbon dioxide is heavier than ambient air, the massive cloud immediately collapsed back down to hug the ground. A 100-kilometer-per-hour wall of lethal gas was moving across the countryside, completely invisible to the naked eye. This topographical map tracks the cloud as it rolled down from the crater, flowing over the surrounding valleys at 20 to 50 kilometers per hour. As the dense carbon dioxide followed the terrain, it physically displaced all the oxygen in its path. The cloud reached the nearby villages at approximately 10 p.m. The gas suffocated its victims faster than the human body could react, causing brief dizziness and total loss of consciousness within seconds. Elevation within a home determined survival. The heavy gas pooled on the ground floor first, killing those in bed while occasionally sparing those sleeping upstairs. This 10 p.m. arrival acted as a total, instantaneous atmospheric replacement across the entire valley, leaving no time for escape. The next morning, responders discovered entire villages collapsed, exactly where the invisible cloud had reached them. The cloud caused a localized mass extinction. wiping out large herds of animals precisely where they stood. The confirmed lethality numbers reached over 1,700 people dead, and thousands of livestock wiped out without a single sound. Survivors who walked through the affected area the next day described an eerie, total silence. Not even a fly was left alive. The 1986 disaster at Lake Nyas left a physical footprint measurable today, a massive, lethal cloud of gas that blanketed the surrounding countryside. While much of the data from that night is debated, one metric is universally accepted. The cloud's volume reached exactly 1.2 cubic kilometers. This volume is scientifically uncontested, derived from cross-verified post-disaster field surveys that mapped the exact height of the gas waterline against the valley walls. But the moment you attempt to convert that volume into the actual mass of carbon dioxide released, the consensus shatters. Published estimates for the total gas release show a massive spread, ranging from as low as 100,000 tons to as high as 1.6 million. This discrepancy is frequently cited as evidence of a fundamental scientific disagreement about the event itself. The missing gas in the archives isn't a failure of physical evidence, but a record of the varying theoretical assumptions required to compute the final mass from a known volume. Calculating mass from volume is impossible without knowing the exact mixture of gas versus ambient air within the cloud. If the cloud were pure carbon dioxide at standard temperature and pressure, the math yields roughly 2.4 million tons, a mass far higher than any estimate. Mass estimates vary based on concentration. Survivors' symptoms suggest a specific lethal threshold was reached, requiring a mix dense enough to cause rapid fatalities. The lower estimates of 100,000 to 300,000 tons relied on outdated sampling models assuming a highly diluted cloud. A 2013 risk assessment paper in Energy Procedia shifted the baseline for these calculations. Modern analysts applied advanced CO2 pipeline leak modeling to the raw 1986 environmental data, solving for the concentration variable. This research established the modern consensus range, between 1.0 and 1.6 million metric tons. That upper figure of 1.6 million tons is now the standard used across geological literature. Risk assessments now treat the 100,000-ton figures as outdated artifacts, rather than equally weighted alternatives. Pinning down this mass is the only way to accurately calibrate threat models for exponentially larger bodies of water. Beyond the weight of the gas, a second discrepancy exists regarding its physical speed. You will find two drastically different speeds in the literature, 100 kilometers per hour and 20 to 50 kilometers per hour. Early researchers assumed one of these measurements must be a localized error. Both speeds are accurate, but they describe two sequential phases of the eruption. Phase 1 is the explosive vertical jet, driven by extreme pressure at the lake's bottom. This initial, violently explosive upward blast bursting from the crater lake's surface reached speeds of roughly 100 kilometers per hour. Understanding the event requires splitting the vertical violence from the secondary horizontal spread. As the upward momentum fails, the heavier-than-air carbon dioxide collapses back toward the Earth, flattening out to form a ground-hugging density current. This current followed the lowest topographical points, pouring through the valleys like a liquid. During this horizontal phase, the cloud moved at a steady 20 to 50 kilometers per hour. This moving wall of gas displaced all oxygen as it crept through the villages. Carbon dioxide at this concentration causes death through instant, invisible asphyxiation, displacing oxygen in the lungs faster than the body can react. The following morning, survivors reported an eerie, total silence, a complete absence of life without any signs of external physical trauma whatsoever. Resolving this kinetic flow explains the speed discrepancy and matches the ground-hugging pattern of destruction. The physics of the cloud's spread dictated its catastrophic effect on the human population. The fatalities across Lower Nyos and the neighboring settlements occurred on a scale that shattered entire communities. Many secondary sources repeat a death toll of 1,788. This figure is incorrect. Investigative checks trace the 1,788 number to a bureaucratic rounding artifact that entirely lacks a primary source. The official toll was established by the UN Disaster Relief Coordinator in Geneva. The verified number is 1,746 human fatalities. The destruction also wiped out the region's agricultural foundation. Roughly 8,300 livestock were killed instantly, exactly where they stood. Aerial photography captured the lethality of the ground-hugging gas, showing entire herds collapsed in the pastures. Removing rounding errors in casualty reporting is essential for respecting the true scale of the disaster and establishing a baseline for future catastrophe modeling. Applying that baseline requires shifting the forensic lens to the 1984 Lake Monoun event. Monoun was a much smaller eruption, but it serves as the critical precursor to the Nyos disaster. Historical literature frequently cites 34 dead during the Monoun disaster. This figure stems from a specific counting error found in early documentation of the event. The number stems from a geographical footnote mistakenly applied to the victims. There are roughly 34 volcanic craters in the surrounding field. The confirmed death toll comes from the USGS and the Smithsonian Global Volcanism Program. The final data point is exactly 37 dead at Lake Monoun. These forensic figures, 1.6 million tons of gas, dual-phase kinetics, and precise death tolls, provide a verified baseline for modeling the risk at Lake Kivu. Early on the morning of August 16, 1984, 37 people were found dead along a road near Lake Monoun, Cameroon. Most were discovered in or near their vehicles. None showed any signs of physical struggle or external trauma. Local authorities were at a total loss. Theories began to circulate ranging from a sudden outbreak of an unknown infectious disease to the covert testing of biological weapons. At the invitation of the U.S. Embassy, volcanologist Harold Sigurdsson arrived at the lake to conduct the first systematic analysis of the site. Sigurdsson began a forensic search for the hallmarks of a standard volcanic eruption. He checked the crater for fresh ash, measured the water temperature for heat spikes, and sampled the air for sulfur. The results were negative. No sulfur was detected, and the water temperatures were normal, ruling out the possibility of a traditional eruption. The absence of these common volcanic signatures forced Sigurdsson to consider a mechanism that geologists at the time had never formally documented. Sigurdsson discovered that the deep waters of the lake were saturated with massive amounts of dissolved carbon dioxide, trapped under the high pressure of the lake's floor. The lake's thermal layers functioned like a pressurized soda bottle. A dense, cold layer of gas-rich water was trapped at the bottom, held in place by a lighter, warm surface layer that acted as a structural cap. He proposed that magma deep beneath the crater was slowly degassing into the water. This gas would accumulate until a physical disturbance caused the layers to mix, triggering a massive release. Sigurdsson submitted his findings to the journal Science in early 1986, outlining how a lake could store and then abruptly release a lethal gas cloud. The paper was rejected. Peer reviewers labeled the proposed mechanism as too far-fetched, finding it difficult to believe that a lake could erupt without a direct volcanic trigger. This institutional skepticism left other communities near similar crater lakes unaware of the specific hazards building beneath the surface. On August 21, 1986, the conditions Sigurdsson had described at Monoun occurred at nearby Lake Nyos, turning the theoretical mechanism into a catastrophic event. A cloud of carbon dioxide moved out of the lake at 100 kilometers per hour. Because it was heavier than air, it stayed low to the ground, displacing all oxygen in the surrounding valley and causing those in its path to suffocate in less than a minute. The scale of the event was immense. Official counts placed the human death toll at 1,746, but the gas was non-discriminatory, killing over 8,000 head of livestock in the surrounding pastures. Survivors described an eerie, total silence following the eruption. The ground-hugging cloud was so concentrated that even insects and birds were wiped out across the affected zones. Approximately 19% of the survivors treated in hospitals suffered from skin lesions, a physical marker of the unique pressure and chemical conditions within the gas cloud. The Nyos disaster forced a global reevaluation of crater lake geology, making it impossible to ignore the mechanism Sigurdsson had identified. In March 1987, the international scientific community gathered in Yaoundé at a UNESCO conference to synthesize the data collected from the Nyos site. It was during this conference that French scientist Jean-Christophe Sabru coined the term Limnic Eruption, deriving it from the Greek limne for lake. Researchers George Kling and W.C. Evans arrived to confirm the mechanical trigger of the event. They were looking for the specific disturbance that caused the lake's stratified layers to overturn. They identified an autocatalytic process. When a disturbance moves deep CO2-rich water upward, the decreasing pressure causes the gas to bubble out of solution. This creates a self-sustaining upward flow that erupts violently from the surface. The physical evidence was found on the cliffs above the lake. Fresh scarring confirmed that a rock slide had struck the water, providing the mechanical impetus for the 1986 eruption. With the trigger identified, the focus of the research shifted from understanding why these eruptions happen to finding ways to prevent them. One final theory remained, the biogenic hypothesis. This argued that the gas wasn't volcanic at all, but rather the result of organic matter fermenting on the lakebed. To settle the debate, scientists had to identify the chemical origin of the carbon. They needed to distinguish between gas produced by decay and gas originating from deep within the Earth. The answer lay in the carbon-13 isotopic signature. Because the ratio of these isotopes differs significantly between biological and volcanic sources, it identifies the gas's exact origin. A 1989 study, led by researcher Kusakabe, found a carbon-13 signature of -7.18 per mil at Lake Manoon. This value is a precise match for gas coming from the Earth's mantle. It proved that the carbon dioxide was being supplied by deep volcanic systems rather than local biological decay. This chemical data officially classified the hazard as a geological process, linking the safety of the lakes directly to the volcanic activity of the planet itself. Today, attention has shifted to Lake Kivu. It holds roughly 300 times the gas volume of Lake Nyos, and its deep waters are continuously recharged by the same volcanic forces. Recent mapping has identified volcanic vents and fault lines directly on Kivu's floor. These structures demonstrate how closely the gas reservoirs are connected to the underlying magma. The region saw a near miss in 2002 when lava from the Nyiragongo volcano flowed into the lake. It stopped before reaching the saturated depths, avoiding a potential trigger. Commercial projects now extract methane from the lake for power, but scientists remain divided on the risks. Some warn that discharging processed water could disturb the delicate stratification that keeps the gas in place. Despite these documented hazards, there is currently no established evacuation plan for the 2 million people living along Lake Kivu's shores. The science of limnic eruptions was established through the tragedies of Manoon and Nyos. Today, that knowledge remains the only available warning for a site where the scale of a potential disaster is unprecedented. As researchers mapped the scale of the gas trapped in the deep, the focus shifted from forensic analysis to an immediate engineering challenge: how to neutralize a lake without triggering it. Standard industrial pumps are useless here. We're looking at hundreds of millions of tons of carbon dioxide held under immense pressure. Attempting to pull that volume to the surface with mechanical equipment would likely burn out the systems long before the lake reached a safe state. Engineer Michael Hallbachs proposed a system that bypasses external power altogether. His blueprint uses the internal energy of the gas itself to drive the water upward, allowing the lake to essentially empty its own reservoir. The process begins by drawing a small amount of gas-rich water into a vertical pipe. As this water rises into lower pressure zones, the dissolved gas can no longer stay in solution. The gas expands into bubbles, which creates a lift effect. This initiates a chain reaction called self-sustaining effervescence. The rising bubbles pull more deep water into the bottom of the pipe, accelerating the flow without the need for mechanical assistance. This setup is effectively a controlled version of the Limnic eruption itself. The same physical forces that could destroy the valley are instead harnessed within the pipe, creating a continuous, stable fountain. By utilizing the lake's own pressure, the degassing pipe transforms a natural hazard into a self-powering system for its own removal. Theoretical modeling gave way to physical testing in 1992 at Lake Manoon, before the team moved to the much larger reservoir at Lake Nyos in 1995. The early prototypes were cautious. Engineers began with narrow pipes, some no wider than a garden hose, to observe how the gas-water mixture behaved in a controlled environment. The margin for error was thin. A pipe that is too small fails to move enough gas to be effective, but a pipe that is too wide creates a massive vertical surge that could destabilize the surrounding water layers and initiate the very disaster it was meant to prevent. After years of data collection, the team identified a specific calibration. A pipe diameter of exactly 14 centimeters provided the maximum possible flow rate while keeping the internal pressure gradients within a safe range. Years of testing and calibration were the only safeguards in place to ensure that the release remained a controlled vent rather than a catastrophic event. The project finally secured the necessary resources in 1999 when the U.S. Office of Foreign Disaster Assistance provided $433,000 to fund a permanent installation. By January 2001, the team was back at Lake Nyos for the final activation. After years of small-scale tests, they prepared to trigger the full-sized pipe for the first time. The activation worked. A continuous column of water and gas began roaring 40 meters into the sky, exiting at 160 kilometers per hour. Because the system is fueled by the lake's own internal pressure, this fountain requires no fuel or electricity to maintain itself. It is a permanent, self-sustaining discharge. This successful activation provided the first evidence that a large-scale degassing system could be safely installed and operated in a high-risk crater lake. While the fountain succeeded, data from the following decade revealed the true scale ahead. Monitoring the lake's chemistry became a matter of routine, long-term observation. By 2012, gas pressure at Lake Manoon was neutralized, and carbon dioxide at Lake Nyos dropped by 40%. But the Earth recharges the reservoir. Yearly, over 5,000 tons of fresh gas enter the lake bottom through subterranean volcanic vents. This continuous influx meant the team had to expand the project. They added more pipes in 2003 and 2011 to ensure they were removing gas faster than the Earth could replenish it. What started as a desperate response to a 1986 tragedy evolved into a 32-year project, reaching a steady-state safety assessment only in 2019. Addressing a geological threat of this scale is not a one-time event. It requires a permanent commitment to maintenance and observation across multiple decades. No single person sees the whole picture. That's why Unveil exists. In the comments, share your perspective, challenge our assumptions, and suggest the next mystery. Together, we see more. Subscribing and liking helps more people see it too. Welcome to the Unveil investigation team. Subscribing and liking helps us keep asking the questions that matter to you. And remember, we unveil so you see.